recording this session, so it will be available immediately after the class. I'll be able to post it. It will be available. And please make sure that you attend the classes. Attend at least 90% of the classes. Remember, this is a quantitative unit, so we need to get the concepts clearly. So the unit is first of look at the the unit. If you checked on the timeline, the course outline is provided. We have 5 topics. We have matrices. Then we also have calculus, input, output analysis. And we also have linear programming. So we will look at them. We will go at a slow pace so that each and every one of us are moving together. Please feel free to seek for clarification. You can reach me through this platform. You can ask questions and I would be able to answer them in good time. So for today, I want us to move to our first lesson, which is matrix algebra. Now, by the end of this lesson, we are expected to define a matrix, that we should be in a position to define a matrix. Number 2, we should also be able to discuss the properties of matrices. And then if we have time, we can also demonstrate addition and subtraction of matrices. So for the determinant and the inverse, we will look at them in our next class. So you need not to worry. Remember, I've said that we are going to move together. So if there is any clarification that is sought, please just note me through the public chat there during the lesson so that I can explain the concepts better. So that is our objective for today. So now okay, some Jefferson, the people who are supposed to sit for this unit, we have groups in business, all the bachelor students in business, and also IT, they are also taking this unit. So thank you for that for that question. So all degree students in business become BAF, BPSM, and BBAM. All of them are taking this unit, and also IT students. So I think that is clear. Now, a matrix, to move to our first item, a matrix is defined as an array of numbers. It is defined as an array of numbers or items, an array of numbers or items. And these items or the numbers are arranged in rows and columns to represent some information. They are arranged in rows and columns to represent some information. So the row is the vertical, and then the columns are, no, the rows are the horizontal. Then the columns are the vertical. So we'll be able to illustrate that very clearly. And remember that the items or the numbers, they are arranged in the rows and the columns to represent a given information or some information. So for example, when we are defining a matrix, we define a matrix given by its number of rows and its number of columns. So that is how we define a matrix. So if we have a matrix maybe with just one column and maybe one row, then it means that that is a 1 by 1 matrix. The row is denoted by letter I. The row is denoted by letter I. Then the columns are denoted by J. So we have I and J. I and J. So I represent the row, the number of rows. The J represents the number of columns. So you can see I've activated a feature there, and some of you are able to also use that feature. You can see from yourself that it is going to be a real, it is like a real class discussion, and I think we are going to have a good time. So please, those who are trying to misuse my pen, I've locked you out because now you are misbehaving. So please let us continue. Let us continue. So we have said that is how we define the matrix, and that is how we define our matrix, by the row and the columns. Now, for a matrix, we have said that the size is defined by its rows and its column. Like if you look at matrix A, in matrix A that we have provided there, we have a matrix of the form A, B, C, D. Now, if you look at this matrix, now the row, the A, B, this one forms a row 1, and these are the C, D there is row 2. So this is a matrix having 2 rows. But now for the columns, we have said they are the vertical. So we have column 1, AC, column 2, B, D. So this is a matrix of 1, 2, 2 rows, and then 1, 2, 2 columns. So this is a 2 by 2 matrix. This is a 2 by 2 matrix. So somebody, Nyagaya is saying he's having a blank page. So let me share again. Let me just share the presentation again. So that he's able to see the presentation. Okay, I hope Nyagaya now you are okay. Okay, so we can move on. So we are saying that the size of a matrix is defined by the number of its rows and the number of its columns. So for matrix A here, sorry, this one should be matrix A. We have 1, 2, 2 rows and 2 columns. But when we come to matrix B, now matrix B, the ABC is row 1, the DEF is row 2, the GHI is row 3. So this matrix has got 3 rows and again the 3 columns. So we have the column from A to G, the other column B to H, and the other column C to I. So this is a 3 by 3 matrix. So we define it by the number of rows and columns. So you just count the rows and then the columns. So when you are asked the size of that matrix, now for our case, for matrix B, it is a 3 by 3. And for example A, it is a 2 by 2. So a matrix can have any order. It can have any number of rows, 2 rows, 1 column. So that will be a 2 by 1 matrix. And we'll be able to show that very clearly. Next, we look at, we can look at a matrix A with 3 rows and 4 columns. Now, this one will now be defined as a 3 by 4 matrix, simply because it has got 3 rows, that is row 1, row 2, then row 3, 3 rows, but the columns are 1, 2, 3, 4. So we have 3 rows and 4 columns. 3 rows and 4 columns, and therefore we will define this matrix as a 3 by 4 matrix. So remember that what we are discussing today is what now we will use for the period of this topic, because we have to know how to define a matrix, we have to know the sets, we have also to know the properties, because those are the things in addition and also in subtraction of matrices. So this lesson today is very important. Please pay a keen attention, and any clarification needed should be sought. Remember, I've said that we can define it as ij. The I represent the row number. The I represent the row number. The J represents the column number. So as A, which is represented as AIJ. So if you can look at where my cursor is, AIJ. So I is the row number and J is the column number. Then we move on to the properties of matrices. Properties of matrices. Now, the first property is equal matrices. Now, 2 matrices can be said to be equal if they meet certain conditions. Number 1 is that they must have the same set. Same set, what we mean by the matrices having the same set is that they must have the same number of rows and the same number of columns. So if it is, yes, okay. So they must have the same number of rows and same number of columns. So if, for example, we have a matrix having 2 rows, matrix A having 2 rows and 2 columns, and matrix B having 2 rows and 2 columns, so that first condition will be met, that they are of the same set, meaning they have the same rows and they also have got the same columns. So in such a case, we can say that those matrices would have met the first condition. But that is not enough. The second condition is that the elements in the corresponding locations, the elements in the corresponding locations must also be the same or equal. So what we mean by the elements here are the B, the C, and the D. So apart from the 2 matrices, same columns, these items here, like A, the position that A occupies here is that it occupies the first row, first column. So again, for another matrix B, which is also a 2 by 2 matrix, will also have A in its place. So the example that I'm showing here is not, the matrix A and B here are not equal because one, the first condition is not met. They don't have the same number of rows and the same columns. But I'm using A just to illustrate what we mean by the elements. So the elements here, the A there, if we would have added another matrix B which is equal to A, it should also have in the first row, first column, an A also. And when you move to first row, second column, the B occupies first row, second column. So in that other matrix, we will also have the same B. Then second row, first column, the C there. In matrix B, if they would have been the same, then it would also occupies the same. Then matrix D, not the same, the element D, which is occupying second row, second column, again, it will also, the matrix B will also satisfy the same condition. So what we have said is that for the two matrices to be the same, then one, they must be of the same set or of the same order. So they can be a 2 by 1, they can be a 2 by 2, they can be a 3 by 2, or a 3 by 3, so long as the two matrices have got the same set, then we can say that they are all equal. The other condition is that the elements in the corresponding locations, and I've shown you the locations that we can have: first row, first column, first row, second column. That way, all the elements, the corresponding locations in that other matrix, they must also be the same. So if those two conditions are met, then we can say that the two matrices are equal. So an example, I don't know whether you can see, if you can see the two matrices that we have there. Yes, if you can see matrices that we have there, we have, first of all, they meet the first conditions because they are 3 by 3 matrices. All of them have it. So I was saying that the two matrices that I've given out there are they are the same, they are equal because one, they have the same set, meaning they have equal rows and equal columns, equal number of columns. Number two, the corresponding elements in the two matrices, they are also the same. So that is the first property, equal matrices. The second property is the column a matrix. Now, a column matrix is also referred to as a column vector, and it is a matrix consisting only of one column, like the matrix X that we have given there. It only has got one column from X1 all the way to Xn. So that is the column matrix. It is just a matrix with one column. Matrix with one column. So that will be referred to as a column matrix or a column vector. Then we have a row matrix, the other matrix, a row matrix. Row matrix. Now for a row matrix, and also show that. So like the matrix, that matrix Y, we have just one row, but different columns. One row, but different columns. 3 rows. It has 3 rows and 3 columns. So to get the transpose of this matrix, we will interchange the rows and the columns. So like in row 1, we have 1, 5, 7 in row 1. So for A transpose, now the row 1 will now occupy column 1. So row 1, column 1 will now occupy column 2. Row 3 will now occupy column 3. So to that, we have shared, and we'll do them practically in our discussion forum. So to get that, remember, this was the original matrix. So its transpose, remember I've said row 1 becomes column 1. So we'll have 157 as our first column. Then row 2, the 2, 1, 4 becomes the second column, 2, 1, 4. Then row 3, 0, 9, 3 becomes now the third column, 0, 9, 3. So that is how we get transpose. Remember, when we'll be determining the limit of a matrix or the inverse of a matrix, this will be of essence to us. So please take note of that. In our discussion forum, we'll look at this, the transpose further. We look at different examples and how we can the transpose, so that I get to know whether you have grasped the concepts. Now, in our next case, for matrix B, we have B1, B2, B3, and B4. This is a matrix, and it is a 1 by 4 matrix. So that is how we define matrix B, 1 by 4, because it has got 1 row but 4 columns. 4 columns. So its transpose, the row becomes now the column. So for its transpose, we'll have now B1, B2, B3 as a column. So it will be, its transpose will lead to a column matrix. So for the B transpose, I hope you can see my cursor. For transpose matrix B, now instead of having B1, B2, the row will now have a column. So you interchange the rows by the columns. For the third matrix, it was a column. Now it will become a row matrix. So matrix C, having C1, X1, X2, X3 as one column. Now, if we interchange the column with the row, now its transpose will be X1, X2, and X3. So that is the transpose of a matrix. So remember, I say to get the transpose, you simply interchange the rows and the columns. And please, when we move to our discussion forum, we will do that further. Next, we look at a square matrix. A square matrix. Now, we can define a square matrix as a matrix which has got the same number of rows and the same number of columns. So if it has got the same number of rows and same number of columns, maybe it can be a 1-1 matrix, meaning that it has got 1 row and 1 column. We can also have a 2-by-2 matrix, meaning that it has got 2 rows and 2 columns. It can be 3-by-3 matrix, meaning that it has got 3 rows and 3 columns. We can also have a 4-by-4 matrix, having 4 rows and 4 columns. So that is a square matrix. Remember, square matrices are defined by their order. The order, if it is a 1, then it is order 1. If it is a 2-by-2, then that is a of say a 2-by-2 square matrix. No, it is a square matrix of order 2, to mean that it has got 2 rows, 2 columns. Now, if it is a 3-by-3 square matrix, then we define it as a square matrix of order 3, a square matrix of order 3, and not a 3-3 square matrix. So please take note of that. And I think an example is there. You have matrix A there and matrix B. They are squares because they have got the same rows and the same columns. The other property is diagonal matrices. Now, for a diagonal matrix 1, it must be a square matrix. So this is the first condition, that it must be a square matrix, but the only difference is that it has zeros everywhere except on the principal diagonal. In some books, the principal diagonal is also known as the leading diagonal. So if you can look at my cursor, the leading diagonal is what I'm showing there, the 317 in matrix A, and then the 900 in matrix B. So a diagonal matrix has got 0 elsewhere except for the leading. In the leading diagonal, the elements there are not 0. So we will refer to that as a diagonal matrix. A diagonal matrix. Next is an identity matrix. An identity matrix. Now, it is also a diagonal matrix. So meaning that 1, it must be a square matrix. 2, it must not have zeros in the leading diagonal. The other third condition is that in the leading diagonal, the elements there are equal to +1. All the elements are equal to +1. Like if we look at the square matrix, the one for R2 of order 2, meaning 2-by-2 matrix, in the leading diagonal, the elements there are 1, 1. So that is an identity matrix. If we look at the square matrix of order 3, matrix I3, again, we'll find that in the leading diagonal, the elements there are all equals to 1. So the elements there are all equals to +1. Not just 1, but it must be a +1. So that is an identity matrix. Remember, when we'll be getting the inverse, we will be making use of identity matrices. The other property is a null or zero matrix. Now, for a null or zero matrix, it is a matrix whose elements are all equal to zero. So if you have a matrix whose elements are equals to zero, then it means that that is a null or a zero matrix. So it has zeros everywhere. Then we have a sub matrix. Now the sub matrix is a matrix that we can obtain from the other matrix by either deleting the columns or deleting the rows. So you can decide to delete just one column, or you can decide to delete one column and one row. You can also decide to delete one row. So that will give you a submatrix. So we get it from the principal matrix. So we can also show an example of that. Again, in our discussion forum, we'll be looking at that. Now, if you look at matrix A having elements 7, 9, 8, 2, 3, 6, 1, 5, 0, this is a matrix A. Other matrix may be A1 from matrix A by deciding to delete the first row. So if we delete the first row, then what we will have is a sub-matrix of 2, 3, 6, 1, 5, 0. And that is matrix A1. So we have just deleted the first row. And then we've got A1. You can also get another sub-matrix by deleting the third column, the column 860. We can delete that. And we also decide to delete the second row. So if we delete the second row, maybe I can show that we delete the first row to get now matrix A. This it will have. Then we can also decide that now we delete the third column and we delete the second row. So what we will have if we delete this, maybe I would have used a different pen to show that. So that is okay. So if we delete the second row, and then we can delete them 2 times to differentiate from the first one. So we delete this, and then we delete this completely. So what we'll have is a matrix A2, and a matrix A2 will have elements 7, 9, 1, 5. So that is also a sub matrix. One can also decide to delete the first row completely. You delete the first row completely. You delete the second row completely, and you delete the third column completely. So we'll have another matrix A3 having just one row, 1, 5, which is a 1 by 2 matrix. So that is how we get the sub matrices. That is how we get the sub matrices. So that is what we have for that today on the properties of matrices. Remember, we have defined a matrix as an array of numbers or elements, and those elements and numbers, they are arranged in rows and columns to represent a given information. Then we have also said that we define a matrix based on the number of rows and the number of columns to give us the set of the matrix. So in our case, we will be dealing with 2 by 2 matrices and 3 at our level, because I know we are from different groups, and so we will not go very much deeper into a 4 by 4 and even 5 by 5 matrices. So I would like us now to move to our discussion forum, and one, we will find the transpose of the matrices that I'll provide there. Two, we'll also find out also the sub matrices that we can get from the matrix that I'll also provide there. So let us kindly move back the way you joined in. You do the same. You do the same. You move back or to subtract the matrices. So in our first presentation, we have just looked at the definition of matrices, and also we have also looked at the properties of matrices. So that will be very helpful for us even when we are adding and subtracting matrices. So the objective of this other presentation is to ensure that by the end of the presentation, you as a student, you are able to demonstrate addition and subtraction in a matrix form. You are able to demonstrate addition and subtraction in a matrix form. Now, we have said that for you to subtract or to add 2 or more matrices, they must be of the same order. So you can't add a 2 by 2 matrix to a 3 by 3 matrix. We can only add a 2 by 2 matrix to a 2 by 2 matrix, or a 3 by 3 matrix to a 3 by 3 matrix. So the number of elements must be the same, the number of elements, not the elements themselves. It is not necessary that the elements in the 2 matrices to be the same. So we can look at an example of how we are adding or subtracting the 2 matrices, but there are some key points that we have to note. One, we have to note that when performing the addition, add each element in the first matrix to the corresponding element in the second matrix. So if we are having a 2 by 2 matrix added to a 2 by 2 matrix, the element in the first row, first column, we will add it to the element in the second row, second column. So that is what we have to note. The other thing, that we have to note is that when when you are subtracting the 2 matrices, you subtract the element in the second matrix from the element in the first matrix. And then remember, the 2 matrices must have the same dimension. What we mean by the dimension is that they must have the same number of rows and the same number of columns. So again, when you are adding or subtracting, the resultant matrix will be of the same dimension again. So when you are adding 2 by 2 matrices to 2 by 2 matrices, the resultant matrix, maybe C, will also be a 2 by 2 matrix. Likewise, when you are adding a 3 by 3 matrix, again, the resultant matrix will also be a 3 by 3 matrix. So we can move on with an example. If, for example, we have been given matrix A, let me just highlight. When we are given matrix A, the one that my cursor is on, when we are given matrix A, the one that my please, when you join, you mute your microphone. The one that my cursor is on, matrix A. So matrix A given by 6, -1, 10, 5, and then 3, 4, 2, -5, -9, -13, -6, 0. If we are given matrix A, and then we are also given matrix B, the one with the 12, 4, -7, 3, 0, -4, 10, -4, and then 7, -3, 7, 9. If we have the two matrices, then we should be able to be in a position, to add them. So when we are adding A to B, Sydney, please mute your microphone. When you are adding A to B, now what we'll do to get matrix A plus B now, you will take the first element here, the 6 that is appearing in the first row, first column, and then we add it to the first element in the second matrix, first row, first column. So that will be 6 now plus 12. So if we add 6 plus 12, that will give us 18 in the first resultant matrix. Then we move on to the second element in the second row. So we have -1. Again, we go to the same element there. We add it to 4. So we'll have -1 plus 4, +4, and that gives us a +3. It is a +3 because when you add -1 to +4, it is like subtracting 1 from 4, and now the sum there will be 3. Then we move on to the third element in the first row, that is 10. We add it to the third element in the second matrix. Again, 10 plus -7. 10 plus -7. And when you add 10 to -7, it is like having 10, then subtracting 7 from 10. The resultant value there will be a 3. Then for the last item in the first row, we have a 5. So you will take the 5. Then we add 2, 3. So that will give us 5 plus 3, and the resultant value is 8. Then we have A there, the second row. Now when we move to second row, the first element is a 3. So we add the 3 to 0. So when you add 3 to 0, the resultant value will be 3. So we have 3 there in the second row. Then we move on to the second element in the second row, a 4. So for the 4, we are adding it to -4. So that is like having 4 added to -4. 4 added to negative 4. So we can also note that we can have a 4, then we add it to negative 4. So if we add this will give us now a 0. It is a 0 because we are subtracting 4 from 4. That will be a 0. Then, so if you look at the resultant matrix here, what we have there is a 0, which is from now the 4 plus negative 4. Then if we move on, we have a 2 there, and then its corresponding element is 10. Now 2 plus 10, 2 plus will give us 12. So if you can see the 12 there, we have the 12. Then we move on to negative 5. Then we are adding it to negative 4. So again, we can show that if we have a minus 5, then we are adding it to minus 4. So it is like having a minus 5 minus 4. So these, the sum there will be a negative 9. Sum there will be a negative. So that will do with the second row. Then you move to the third row, again negative 9. We add it to 7. So that will be like having a minus 9. Then we are adding to positive 7. So in such a case, our resultant value is minus result 13, negative 13. We add 3, negative 13, adding to negative 3. That will give us negative. That gives us a 9. So that is how we add two matrices. That is how we add the two matrices. Now, if we continue, when now you are subtracting, you are now subtracting the second matrix B from A. Again, we follow the same procedure. We will also follow the same procedure, but now we will not be adding, we'll be subtracting. So you will be subtracting the 12 from 6. So you'll have 6 minus 12, and that will give you a negative 6 as the result. Then we will have negative 1. Again, you subtract 4 from it, negative 1 minus 4. So negative 1 minus 4. A minus and a minus becomes a plus. When you subtract the negative 1 from 4, the minus and the minus becomes a plus, and therefore now we'll have 3. Then we have the next one, which is 10 minus 7. 10 minus 7. So a minus and a minus becomes a plus. So we'll have 10 plus 7, which is now 17. Then we have 5 minus 3, that gives us a 2. 5 minus 3, that gives us a 2. Then the next row, 3 minus 0, that gives us a 3. 4 minus 4. So again, a minus and a minus will become a plus again. So again, we'll have 8. Then 2 minus 10. 2 minus 10, that will give us a negative 8. Negative 5 minus 4, that will give us negative 5 plus 4, which is a negative 1. Then next we have negative 9 minus 7, that is negative 16. Negative 13 minus 3, that is negative 13 plus 3, that gives us again a 10. Then we have negative 6 minus 7, that is negative 13. And then 0 minus 9, that gives us minus 9. So that is what we wanted to show you in the addition and subtraction of matrices. So again, when you are subtracting or adding matrices, one, you must ensure that the two matrices are having the same order or are having the same set. So I believe that we can look at an example in our discussion forum. So please, we can move to our discussion forum. So I'll end this session, the live session, so that we communicate in the discussion forum. So I'll end the live session, then we move to discussion forum.